In this video, we will talk about some of the common and newer approaches to distributing power within a data center. The feed from the electric grid is fed into the server room that houses the data center equipment. In order to improve reliability, data centers typically have some form of redundant power supply that can be used in case of a power grid failure. In most cases, an on-site backup AC generator is used that can handle the load of the entire data center. The AC generator typically runs on diesel fuel or natural gas. Since the backup generator requires anywhere between 15 to 45 seconds to start, and to keep the equipment alive during this time, a UPS system is present within the data center to provide uninterrupted power feed to the equipment. The UPS has two internal stages. The first converts AC to DC to charge the batteries, and the second stage does a power conversion back to AC. During a power failure, only the second stage would be active. This power is fed into individual racks using power distribution units or PDUs. PDUs can be thought of as power strips that are used at home but are designed for much higher loads and have many features to support redundancy and management. Power from the PDU is supplied to individual servers which have individual power supply units that convert AC current to DC and provide multiple voltage levels for each component in the server, typically 5 and 12 volts. The primary disadvantage of this traditional model is the fact that repeated AC to DC conversions are at most 95% efficient, and at large scale those 5% power losses add up. The high voltage direct current distribution model, or HVDC, is being investigated as an option to make power delivery more efficient. In this model, a central AC to DC rectifier converts AC to DC once and supplies high voltage DC at 380 volts to each individual server. Each server steps the voltage down for individual components. In the dual feed approach, both AC and DC power are sent to each server through individual PDUs. The AC feed acts as the primary and the 48-volt DC feed acts as a backup. In this model, each server has a custom power supply that can handle both AC and DC input feeds simultaneously. This allows power delivery to be efficient while running on mains power, and the batteries are used only during a failure, long enough for the generator to turn on. In the Google approach, each server is built with its own battery backup. This removes the needs for multiple AC to DC conversions and enables battery replacements to be done at the server level.